Good morning, everyone. My name is Timothy Lee Grant. I am exhausted because I just got off of work, but I am not going to let that stop me from doing Leetcode. I want to do Leetcode every day, keep pushing forward, don't give up, go forward, 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 no matter how tired I am. So today, just like I was doing in the past, I don't know what problem I am going to be doing. This is completely unscripted. I don't know if I'm going to be able to solve it or not be able to solve it. The previous two videos that I did, I was not able to solve it by myself, so I had to declare defeat. But then after declaring defeat, tried to go and figure out like, okay, well, what was my problem? What was my misunderstanding? How do I need to improve so I can become better for next time? So without further ado, let us move forward and start this Leetcode problem. So let me just get that there. And let's see, what question, what section do we want to do? Let's see. I'm thinking something backtracking. How are we feeling? Backtracking? Let's see. I don't like that. They're all mediums. What about some easy stuff? I'm seeing two easies. Not many easies actually. Sum of all XORs. All right, let's just do the first easy that we see. Let's try it. Okay, come on. So, here we go. Given the root of a binary tree, okay, so we're given root, and root is a node up here. So root has the properties of value, left, and right. So given the root of a binary tree, return all root to leaf paths in any order. A leaf is a node with no children. Okay. All right, so first off, thinking about like what is it asking, trying to understand the problem. So we're given this root of a binary tree, return all root to leaf paths in any order. So I'm looking at this photo. One path should be like bam, bam, right? So starting at the root, come here, and then I've reached uh, a leaf because it has no children. So once I get to a node that has no children, I need to return this path right here, okay? And then I also need to come and do 1 to 3. This is also a valid path right here because starting at the root, I come down here and there's no children. So then I know that, okay, I need to return that. All right, so thinking about how to do this, I see that it is a tree, so I know that I need to do recursion to traverse this tree. So I'm just going to, oh, I should continue to read the problem. Let's see. So root equals okay, so we're just given the tree, yeah. And then we need to return. Does it have to be in this format? This kind of like it. Okay, so it returns a list. So it returns a list of strings. So I guess it does need to be like this arrow format, not like 1, 2, 5 with separated by commas. Okay. Then so yeah, 1, 2, 5, and then separate it 1, 3. Okay. So then constraints, the number of nodes is 1 to 100. Okay, I don't think that really matters. And then node values are negative 100 to positive 100. Okay, that's it. All right, so let's see. I know that I need to do recursion. So, and I also know that I need to have like an answers list. So answers equals, and I'm going to have an empty list. Okay, so def recurse. Okay, and then that's just going to be passed for now. And what do I want this recurse function to do? I want it to, okay. So I know that I'm going to be passing in a node, right? And thinking back, so I did backtracking a long time ago, maybe 4 months ago, I studied backtracking. I remember that you do like the basic idea behind it was you recurse through all the possibilities. So I want to start here and then I want to go down. And then, so I'm going to go left, then try to go left, and then try to go right, then try to go left, try to go right. And then how do I know that this is a leaf node? So I can just say, I can just check like, if not, uh, uh, whatever the node that I pass into the function. So if not, I'll call this like, what should I call it? I don't know. Node. I don't think that's a keyword, right? No, it's not a keyword. So I'm just gonna call it node. So the way that I can check if it is a leaf node is I can go like if node dot left and not, so if not and node dot right, then I know that I found a leaf node. Okay, so this is the leaf node case. So at this point I want to append this path to my answers list. So I know that I need to be, every time that I use this recurse function, I know that I need to keep track of kind of like my history, like where I've been coming from. So let me see. I'm just gonna say like, if not, okay, so if I do not have this, I am going to current path dot append. No, it's gonna be answers dot append, and then I want to append current path. Let me current path equals, and it is a string, so I'm gonna put an empty string here. Okay, so this is kind of like a base case, right? So return, because once we hit this, we don't want to really do any recursion anymore. So what are the other cases that could happen? So if it didn't hit this base case, I know that I want to go to the left of the node. So if node dot left, so if the left node exists, then I want to do I go to it or do I append the current one? Because what I'm trying to do is figure out, like, with this current path, I need to append this current path, right? So what I'm thinking is I have this node here that I'm currently at. That's where I pass in. Let's first start at the first node that I'm here at this root node, and I need to append this current node, right? To my current path. And then I'm going to come down here and then also append this node. And then I want to come but it's not going to hit because this is not a valid statement. This is going to be false. So far I have here and here, and then I want to go right and append this one. Yes. And then I want to check here and here, and then put that into the answers, the current path into the answers array. And then I want to pop up, and when I pop up from traversing right, then I want to take away that node that I just put there. I want to take that away from the current path. So when I pop up, answers.append, should I put it here that I'm... Or is it like, plus equals, of node dot val. But then for the first root, this is going to always append that like little arrow thing to it. So that's not very good. Do I need some way of knowing that I am... Okay, that's not going to work. Thinking, how can I determine if I am the first node? Okay, what I might do is kind of like this. If root, then I recurse with root, and under this case I can do current path equals, and then I can just change it and then I can do formatted like this, and then root.val, and then else, what do we want to return? Does it say what to do to return if there is none? Oh, that's it's guaranteed that there is at least one node. Okay. But otherwise, I'm just gonna do that. Okay, so this case won't happen. This else case won't happen because it's guaranteed by this constraint here that we do have at least one node in our tree. So that's not going to happen. But this case right here, so first I am appending this value to the path, which is current path, and then that means what I should do is if we find a node, we find left, we want to append this left and then recurse on that left. Okay, so I want to current path plus equals a string of arrow value of node.val. Okay, this is formatted. Okay, then I want to recurse on that. Okay, so what? Node dot left. Okay, and then when we pop out, okay, so when we pop out, that would be from here to here. So we pop out. We want to take this node off, right? Yeah. So then current path how am I going to, I can't do like minus equals. And I also can't, because the value could be 1 digit, it could be 2 digits, or it could be 3 digits, or it could be 4 digits, right? It could be positive, or it could be 0, which would be 1 digit. 0 through 9 is 1 digit. And then it could be positive 10, which would be 2 digits. And then it could be positive 100, which would be 3 digits. Or it could be negative 100, which would be 4 digits. So I can't just like subtract the array. Maybe I can do like a I don't know, remove character, remove value like this, and then I pass in node.val and the string that I want to do or get rid of. Let's see, so def remove value val and string. Okay, And so this function is going to look at the val. So it's going to look at the value and then remove that value and the arrow. Okay, so path equals. Okay, so I'm going to implement this later, and I'm right now just going to assume that I have that implemented. So this is kind of how I'm going to be removing that. Okay, so that's when we recurse. After we do the recursion through the left, then we pop up out, and so I want to remove that. If node.write, then I essentially, oh, I see that actually this is wrong. Let me just copy and paste that. So I want to actually append the left value. So it's actually node.left.val. Node.left.val. And so in this case right here, what I said that I wanted to do was I wanted to, okay, I see that this root does have a left value. So I want to go down and I want to append this value to the path, and then I want to then recurse on that and visit all nodes within this path. And then when I pop up, I want to remove this path, this one right here, which is this guy's child. So that's why I need to subtract or take away that specific value. Okay, so now this one is node.write.val, node.write. Okay. So I'm going to try to think about how to do this. So, can I just do, like, if val is greater than 99, so then we want to remove 2. Okay. If val is, let's see, so that's the, no, we want to remove 3, right? So, because it's greater than. So that's like in the, that's the positive 100 case right here. Positive 100 case. Then if it is between, so elif val is greater than 9. So this is the case that it is. So I'm just hitting lower and lower and lower, and I'm going to hit all of those brackets that it could be, and then just remove that number of characters, and then remove the arrow. That's kind of my idea. I am sure that there is a better way, but this is just what I can think of right now. So if val is 9, I need to remove 2. 2 characters. So then, whoops, pass, okay. Elif val is greater than -1, and because 0, I also want to just remove 1 character. Elif val is greater than, and then this one is going to be, if it's greater than -10, and then so that corresponds to negative, like -9. Okay, -9, I need to remove 2. Okay, well, if val is greater than negative, let's see, -100. Okay, this case I need to remove 3 characters because it's going to be -99, so negative sign, then 9, then 9, so 3. Elif val equals -100, and in this case I need to remove 4 characters, okay? So now let me come back up here and figure out how to remove these 4 characters. So let's see. Can I do something like this? Equals string and then starting at 0. So I want to include everything except length of string minus 3. Can I do that? I don't know if I can do it, but I'm gonna try. Let me see. So if I have something like hello there, okay, the length function is going to return 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to len equals 11. And I want to index that from 0. And let's say I want to cut off 3. So I want to index it from 0. So the 0, 1, 2, 3, 4, 5, 6, 7. So 7, right? Want 0 to 7. So 0, 1, 2, 3, 4, 5, 6, 7. Because I want to include this h here. Yeah. So that 11, 10, 9, 8, 7. So it's actually going to be the length minus 4. Okay. Should be like that. I'm just gonna put this in for all of them. So this one is remove 2 characters, so I want to do 3. 1 character, so I want to do 2. And then this one I want to do 2, so I want to do 3. This one I want 3, so I want 4. This one I want 4, so I want 5. Okay, so I removed that value. Now I want to remove the arrow. So now string equals string 0 to length of string, and I said that I want to remove 2 of them, 2 characters, 1, 2. So I actually want to get the 3rd index in. Okay, and then return string. Okay, so return and then answers. Is this even like logical? I think so. I think it's logical. Oh, outside function? Wait, what? Is it not indented correctly? I think I need one more. Like this, right? Yeah, that should be the correct indentation. Oh, what's up? Current path. Oh, I hate that. Okay. That's so dumb. Okay. I don't want to do like self dot because then I need to change it for all of them. Can I do like global? Global? Is that like, would that work? What is the syntax in Python? Because, okay, now what's it saying? To current path. Cannot access local variable current path where it is not associated with a value. Okay, I guess I have to do this self because Python is okay. Self. I'll just copy and paste this. Self, and I also want to do for answers self.current path, current path, current path, current path, current path, current path, current path. Did I get all of them? Self, 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 self. I think so. And then I got both the answers, self. Oh, this is the only thing that I need to do. Okay, so, and then self. And, yeah, obviously. Okay, let's see. There's no attribute not left. So are we hitting any case where the node itself, if not, so what I'm thinking is somehow this is hitting a case where we're passing in a root that doesn't exist. Like we're passing in null and then trying to access one of its fields. So we're trying to do like we pass in a non-existent, or like here we try to pass in a non-existent node and then access its child, but obviously we can't dereference a null pointer. So there's something wrong with my logic, because I thought I set my function up in such a way such that I wouldn't have any null nodes sent to my function. So there's something wrong with how I'm operating. So if not, node dot left. So the first time I guarantee that there is a value. I guarantee that there is a node. So I'm passing in a node. So if not left, which should be fine because this node would exist, but this would be null. And not node right. So the only time this will trigger is if both are non-existent. Okay, then we do this. Then if node dot left, if there is a node to the left, oh, yeah, well, there we go. It didn't crash. It didn't crash. It's not right. But it didn't crash. Okay. Let's see what's up here. So, 为什么？为啥？这是什么意思啊？为什么加了一个一在这儿，但是没有在这儿？What's going on? What's up? What's going on? Come on, come on. Oh, okay. So there is a difference. So this is the second one. So what happened here is it went here, and then here, and then nope, and then here, okay, and then it took away this one, and then it took away this one, and then we recursed up here, and then apparently we took away this one, which is not what we want to do. And then we went here and added this one, which is what we see here. So we took away this one. We don't want to take away that one. We want to keep that one and put it there. But again, this also brings up a problem, because according to the way I thought I implemented things, I thought it was the case that I always append the node that I will be going to, and then I take away the node that I just that I just added. So I never touched this. Like, I first added this one to current path, and then I didn't think that I ever touched it, right? Because if I'm thinking about this, I come here, I add this. I'm just gonna think about the case where first off I just have, let's say that I have 1, 2, and 3. Okay, this guy doesn't exist right here. Bam. So I add a 1 to current path, and then I'm up here. Then I immediately Nope, I'm not in the remove, I am in the recurse. So I come to recurse and current path is 1. Okay, right? Yep, without the arrow. Yep, good. So then I will, it does have a left node, so this case does not trigger. We come to here. It does have a left node, so this case does trigger. So then I add so it's 1, and then I add arrow 2. Okay, so 1 arrow 2. So that's what we have. 1 arrow 2, and then I go into this 2. Okay, and then I'm back up here. It doesn't have a left, and it doesn't have a right, because we said that we're not considering this. We're just doing this tree. It doesn't have a right, so then we add 1, 2 to answers. Okay, that's correct. That's what we expect. It's one path from the root to the leaf node. Okay, and then we return. So then we're back here. Then I remove. So this is going to be 2. So then I come up here and it is greater than -1, so it's in between here. So I take away this. No, it's not greater than 9. It's here. So I take away 1. So the 2 drops out. And then the arrow also drops out. And then I return that. So now I just have 1 after here. Which is correct. That's why I'm confused. It's 1. And then we come down here, and because we see that we have a right, and then we add 3. Arrow 3. 1 arrow 3. It's not... it's 1 arrow 3. I don't... Plus equals, plus equals. And all of these are indexed at 0. Okay. Did I put something like left, left, left? So all of these are left. All of these are right. So why would it be the case this one I got right? Oh, but it's just 1. I this is that feeling that you're like No, the output is wrong. My code is correct. The standard output is wrong. That's what's up. That's what's going on. Man, it really feels like that sometimes. So some little goblin came in and took away my one, my character one. That's what happened. Man, come on. Come on. Put it back. Put it back. Come, don't, quit playing with me. Okay, so because I'm removing the one that I just added. I never touch the node that I'm currently at. That's my big so this node, that's what I am currently at, right? And so initially I pass in the root. Okay, so I'm at the root. Now, in my function, in recurse, I do not touch the current path variable for the node I am currently at. I only touch it for its left and right. Okay. Is that correct? So the right child and the left child. I don't touch it, right? So current path plus. So I'm gonna look at every time that I touch current path. Okay, so I am not changing current path here. Current path is remaining the same. Okay, I'm not touching it. Current path. I am changing it. I am changing it. I am adding left value. So I'm adding the left node. Okay. Then here I am also changing it. I'm taking away the left node from current path. This one, I'm changing it. I am adding right value. Yeah. And then this one, I am taking away right value. Okay. Now, this is outside of the function. I'm not touching the root node should never be touched. Root node should never be touched. I'm just going to run this again. But I don't touch root node. I don't touch it. How? How is that possible? Why? How? I man. I really don't want to declare defeat. This would be the third easy problem that I've declared defeat on in a row, and I've only made 3 of the video. I've only made 3 Leetcode videos, and every single one of them I failed. Man, I am never getting into a top tier company. I can't even do easy problems. Oh my gosh. Never getting into a top tier tech company. Oh, that sucks. All right. I really don't want to declare defeat on this. Cuz I feel like I should know it. I feel like it's just some little thing that I'm not thinking of or I don't see. I've really. Come on. How? How is it removing this one? How is it removing? It should never remove the current node value from the list. See, I do node left, then node left, node right, node right. Nowhere in here is, unless one of these things is wrong. Unless one of these things is wrong. So, what did I say? This one is 2. So that's in here. So I want to remove 1. And then I want to... What I'm thinking is it actually might be in this function. And the reason that I say that is because if you look here, it says 1, 2, 5. So I append 1, I append 2, and I append 5. Okay, then I take away 5, then I take away 2. And then when I come here, I take away 5, I take away 2, and then I come here. But if I took away values, if I took the string and made it indexed incorrectly, come to think of it, 1 and 2. So if each time I removed a character, removed that value from the string, if each time I did it twice, I removed it once, I removed it twice, at that point, it would slip. What I mean by that is if I took away too many characters each time I removed one of the nodes, then at the end, when I get up to this number 1, I've taken accidentally too many characters off, and all of a sudden I have an empty string now. So, and also come to think of it, doesn't this length actually... No, doesn't the, like, slicing automatically deal with, like, it's non-inclusive or something? So for 3, 2, isn't this... I think slicing arrays is, like, non-inclusive. Like, it goes from the start, which is 0, and then to the stop, but doesn't include the stop. If that's the case, then I am taking away too many characters each time I do a remove. So this should be 2. This should be 3. Okay, and then this should be 4. And then this should be 2, because it's the arrow. Okay, so it should be 3, 3, 2, 2, 1, 1, 2, 2, 3, 3, 4, 4, and then I take away 2 for the arrow. So I'm just gonna try doing the submit. Let's see. Wait, it passed. It passed. It passed. It passed both of. It. That's what it was. That's what. Yes. 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 Okay. 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 Here we go. Here we go. Oh my gosh. Oh my goodness. I got it. I got it. I'm so happy. I'm so happy. It's 10 o'clock at night right now. Got off of work. I got it. I got it. I shouldn't be this happy about solving an easy problem, but I am. I'm excited. I'm ecstatic. Oh my goodness. I love. Okay. Okay. Oh, my heart is like all the stress went away. All the stress. Because I was thinking, I was like, man, I should know how to solve this because I felt like I was so close and that there was just one little thing, and I almost declared defeat and just went to what I was going to do is go to the Microsoft Copilot, right? Put in the problem, ask it, and let it know, like, describe the situation. I was going to say, I'm getting an error where I'm observing that the root node is being removed from the, what did I call it, current path variable, such that, and then show the output which I was getting, which my program was giving, and then say, where is this located? What would you suggest? And kind of talk through it so that I could not just get the answer but understand why I made that actual error. So I was so close to actually just declaring defeat and just saying like, okay, I have to figure that out. But I felt like I was so close on the precipice of actually getting it. So I was like, oh, that feeling was like, oh, I'm so happy. I'm so happy. Okay, success, success, success. All right, I'm exhausted. I'm gonna go sleep. So I hope you guys have a wonderful day, and I will be making another video tomorrow, and we're gonna try another Leetcode problem. So subscribe if you would like to. That would be awesome. And so yeah, I will be back tomorrow. Have a wonderful day, everyone. Thank you guys for watching. I'm so happy I got it. Okay. All right. See ya.